How did the Romans move water for entire cities? Let's rebuild their secret. Roman aqueducts are some of the greatest engineering achievements in human history. They weren't just beautiful structures, they were the lifelines of entire cities. And what's even more impressive is that the Romans built them more than 2,000 years ago, without pumps, without engines, and without modern machinery. To understand why aqueducts mattered so much, we need to step back into the world of ancient Rome. At the height of the empire, the city of Rome alone had more than 1 million people. No ancient city before it and very few after reached this scale. But a city of that size has one major problem: water. A lot of water. Drinking, cooking, cleaning, farming, sewage, fountains, public baths. Every aspect of Roman daily life required enormous quantities of fresh water. Local rivers and wells simply couldn't keep up. So Roman engineers did something revolutionary. They created a network of aqueducts stretching across mountains, valleys, and entire countrysides, bringing clean water from distant springs straight into the heart of the city. The genius of aqueducts lies in how simple the concept was. Gravity. All they needed was a constant, gentle downward slope from the source to the city. Even a tiny drop, sometimes only a few centimeters per 100 meters, was enough to keep the water flowing. This required incredibly precise surveying, using tools like the chorobates and groma, instruments that allowed them to measure angles and heights with remarkable accuracy. Whenever the terrain dropped too low, across a valley, for example, the Romans built the famous arched bridges we recognize today. These arches weren't just aesthetic. They distributed weight perfectly, allowed the structure to be tall and stable, and required less material than solid walls. Some aqueduct bridges, like the Pont du Gard in France or the Aqua Claudia near Rome, are so well built that they're still standing with minimal restoration. And they weren't small structures either. Many were over 50 meters tall, built entirely from stone, fitted together with such precision that no mortar was needed in certain parts. One of the most surprising things is that Rome had so much water that they used it to flush their sewers. Their wastewater system, the Cloaca Maxima, is one of the earliest large-scale sanitation systems in the world. Without the aqueducts feeding it, the city would have faced constant disease outbreaks. Of course, building these aqueducts was incredibly labor-intensive. Teams of surveyors, stonemasons, engineers, slaves, and soldiers all worked together, sometimes for decades, carving tunnels through mountains, building bridges across entire valleys, and maintaining perfect slope across huge distances. Yet despite the scale, the Romans were incredibly efficient. Many aqueducts took fewer than 10 years to complete. The legacy of Roman aqueducts survives today in countless ways. Modern water systems still rely on gravity-fed channels, pipes, regulators, and distribution tanks, ideas perfected by the Romans. Some European cities still use original Roman aqueduct foundations for their water networks. Looking at my Kapla reconstruction, what I've built here is inspired by the long arched bridges Roman engineers used whenever they had to cross a landscape that dropped lower than their ideal slope. Each arch in this Kapla model represents the same principle the Romans used: strength through balance, symmetry, and geometry. Although mine is built with wooden planks and theirs with stone, the engineering logic is the same. Roman aqueducts weren't just structures. They were a revolution, a system that let a civilization thrive, expand, and reach a level of urban comfort unmatched for centuries. And rebuilding one with Kapla is my small tribute to their ingenuity.